Hello, my name is Joel Haight. I'm a professor of industrial engineering at the University of Pittsburgh. But after a long career of 41 years and a lot of research in the area of safety and health, I have accomplished a couple of things that I think the safety community needs to look at. And I'm not just a pure academic researcher. I spent the first 18 years of my career in industry, and then have been a professor and researcher for the last nearly 23 years. And so I am always puzzled, have always been puzzled by how lightly we touch and address measurement. And I think it needs more, and this is one way to do a more and deeper analysis of that health and safety management system measurement. So we know that billions of dollars are spent each year in industry to pay for injuries, medical, lost time, lost productivity, and so on. And one of the most expensive resources for companies is the human resource time. And so some companies commit as much as a third of their available human resource hours to activities that are meant to help prevent injuries. But most companies do not measure the effectiveness of those commitments. So I came across this interesting photo, and it shows in the top photo what we would consider a leading indicator. And our goal is to shoot 60 arrows per minute or per hour or whatever the units are there. But if you're just shooting arrows into the breeze, are you really measuring anything? So a lagging indicator would be some measure to show that you've hit the target that you're interested in. And in the case of health and safety management, the target is a reduction in injuries and a reduction in risk. So what we have to do is to tie those two together mathematically. In sports, this is a big consideration. You know, we hear a lot about the statistics in sports, like the yards per carry in a football game. Do we count that, or do we count winning the game? Winning the game is the outcome. That's the lagging indicator. Do we count rebounds or victories on the basketball court? Shots on goal, or winning the gold medal in Olympic soccer or hockey? Even though the final score is important, and that's our goal, it helps to understand how all of those other variables can contribute to or do contribute to that final goal or that victory or that gold medal. And in health and safety, it's really not any different. So in this diagram, which comes from some of my research, we see on the left side all of the resource commitments, or a representation of them, feeding into a health and safety management system, and the outcome variable, or the injuries, or you could have risk as an outcome variable. We have to draw the mathematical relationship and watch how the lagging indicators change in response to a change in the leading indicators. And that's an important step in the process. And so it's been relatively consistent through all of the studies that we've done that as you put more resources into prevention, the incident rate comes down. It comes down in the form of this negative exponential curve, but at some point that curve flattens out. And if we can determine what that line looks like, what that curve looks like, we can determine where that point is. And as you can see on the curve, for a significant increase in the resources that are input to the process, you look on the green, written in green on the x-axis, you don't get much of a reduction in the incidence or the output variable of risk. So why continue to put more resources into those activities? More is not necessarily better in the safety field. We sort of allow a humanitarian view to take over and think that the more we can do to save workers, the more we should do. And that's not necessarily true, because there is a business to run. So to find out where that point is, where the curve flattens out, it is an important part of this research. So all of the work that I've been done has been done in field operations. The first studies were done in the forestry division of a power company. The second was done in an oil industry. And so these are real numbers coming from real companies. And we have been able to show that there is a relationship and there is a mathematical equation that describes the relationship between the lagging indicators and the leading indicators. And that equation is very powerful because we can manipulate that equation to give us predictable results. And what I mean by predictable result is raising or lowering of the risk or raising or lowering of the numbers of incidents. And the more we're able to do that, the more efficiently we're able to zero in on the right resources to minimize incidents while concurrently minimizing the commitment of resources. So the model, now this is just that, a model representing the equations. The equations are quite involved, but we're still defining this result, this negative exponential curve. You can actually do a lot more fancy and involved statistical analysis here, and this method of surface response analysis shows the point with two variables in a 3D graph where you're minimizing the incident rate. So you can see at what point how much of a commitment of one of the factors versus how much of a commitment to one of the other factors in a health and safety management system where you can hit that minimal point. And so that's the goal of this research, is to try to effectively and efficiently minimize risk, minimize incident rates, while still concurrently minimizing the commitment of resources to the activities of the health and safety management system. So there's a lot of statistical techniques such as what we just saw, the surface response design and those contour plots that are used to obtain the desirable incident rate. Now, we don't desire an incident rate, we want to minimize that, and so that's really what we're talking about, is the minimal incident rate. And so if we know where the point is with additional allocation of resources to safety interventions, they don't necessarily need to reduce incident rates. It's crazy to input those resources. And in fact, in one study, we determined the point where the curve starts to flatten out was at a commitment of about 15% of their available resources. And they were committing as much as 36% of their resources to prevention activities. That's crazy. In a 400-person organization, that difference from 15% to 36% is a significant input of both cost and people power. I would want to do something more productive or more efficient with my manpower if that were the case. So you can achieve the desirable incident rates while concurrently minimizing the use of available manpower. And if you're able to reach that, with the maximum constraints on available manpower, but as yet we haven't achieved the desirable incident rate, we use other modeling techniques and continue to explore additional interventions, additional aspects of those interventions, such as the quality. It's not all about the quantity of the input, it's also about the quality of that input. So hopefully we will see this. We'll see more effort to try to achieve those minimal incident rates, minimal risk, by more mathematically understanding our process. So lots of discussion in the safety community about whether or not we can measure performance variables, and that leading and lagging indicator discussion has gone on for many years, with most of the people leaning towards leading indicators. My challenge here is that we have to lean towards the relationship between the two. So All of the papers that have been written out there, and there's a couple of other researchers in addition to the research that we've done that are starting to come out to indicate that we can, in fact, develop that mathematical relationship. There is the young gentleman from the Construction Consortium in Denver has written a number of good papers in this area. But with this mathematical relationship, design and optimization of your health and safety management can be accomplished. So hopefully you will, this message will get out and the people will, in fact, accomplish that goal. And this is just an example of how this information is used. This printout was from the system that took all of our modeling results, and we were able to, with certain inputs of specific activities at specific levels, we were able to calculate an output and then get a recommended design for the next week or the next month or over the next year of what the health and safety management system should look like. So that is accomplished. It can be accomplished by anyone who has expertise in IT to develop something like this. But safety and health professionals everywhere should be looking at the relationship between the two.